So this is question 7. This one talk about a tourist luggage bag given as 20 kilogram with a force at a constant velocity. So keyword of the motion is constant velocity, right? The coefficient of friction is given is 0.4. So usually they will give you the frictional force, but this question they only give you the coefficient of friction. So the luggage is dragged through 0.8 meter along the floor. So they ask you to calculate work done on the luggage by few forces: normal force, external force, and gravitational force, and also the frictional force. So to start off with this question, what we need to do is to draw free body diagram for the system. So in this case, the first one will be your external force, and then this is the ground. So normal force is perpendicular to the surface, and frictional force is opposite with the motion. So I'm going to draw the direction of displacement, which is to the right along the horizontal surface. And one more force is weight, which is downwards. So once you have identified all the correct forces and the correct free body diagram, alright, so what we need to do is we need to construct a table for all the forces. So in this case, alright, x-axis, y-axis. So the four forces involved for the system: normal, external force, weight, and frictional force. One thing not to forget is the angle between force and displacement. So it's 37 degrees. So what we need to do is, firstly, we need to fill in all the rows in this table. The first one will be normal force. So normal force will be 0, positive n. External force, we have to resolve the force into x and y. So this one will be to the right, F cos 37. This one will be upward, so F sin 37 degree. Weight is pointing downwards vertically, so it will be negative W. And frictional force is to the left, so I'm going to put negative F, 0 here. Now in this case, one of the indication here is the object moving at a constant velocity. So this one pointed towards Newton's first law, right? Newton's first law states that summation of force must be equals to 0. So I'm going to fill here summation is equal to 0. So from here I'll be able to construct two equations, right? So the first equation from y-axis, so for this axis, so I can construct one equation which is n plus f sin 37 degree minus w is equals to 0. So I'm going to rearrange this equation, right? I'm going to rearrange. I will end up with n plus, so f sin 37 is equals to, this one I'm going to substitute weight with mg 20 multiplied with 9.81. So this one will be our first equation with two unknown, n and f external force. Alright, so once we've done with the y-axis, now we proceed with your x-axis, which is this one. So I'm going to construct another equation, which is f cos 37 minus with frictional force is equals to 0. So rearrange the equation, alright. I'll be able to get my frictional force. I can expand it, alright. So I'll end up with negative mu n plus f cos 37 is equals to 0. I'm purposely rearrange the equation so my n will come first, and then after that is my external force. So this one I'm substitute in the value for coefficient, which is 0.4, n plus f cos 37 is equals to 0. This one I'm going to put it as my equation 2. Now I have two equations with two unknown, alright, which is N and external force. So what we can do after this, we can use our calculator to calculate simultaneous equation, or if you want to do substitution, no problem, right? You can do that. So the fastest way is to use calculator under mode 2 unknown, 2 equation. So I'll end up with my normal force from the calculation is 150.79 Newton. So my external force here should be equals to 75.5 Newton. So once I get the value of normal force and external force, I can go back to our questions now. So the first part, they ask us to calculate what is the work done by normal force. So using equation Fs cos theta, so my normal force, my external force, my force will be normal force. So I'm going to replace the force with normal force, alright? So this is normal force, work done by normal force. Substitute in the value, alright? Since that we have the normal, but I don't need to substitute normal since that I know that the angle between normal and displacement, normal, displacement, angle between them is 90 degree. So if you substitute cos 90, you will get 0 here. Alright, so I'm going to maybe fill in here. So 90, so cos 90 is equivalent to 0. So I will end up with 0 joule. No matter what normal and displacement I substitute in, it will always be 0. So done with the first part A. Part B, the question asks us to calculate work done by luggage force. So luggage force, I'm going to use equation. This is external force. So Fs cos theta, substitute in our external force from the calculation early on, which is 75.5, displacement 0.8, and then cos angle between external force and displacement, which is 37. So cos 37 degree. So here I'll be able to get positive 48.24 joule. So this is my value for work done by external force. C, right? C, the question asks us to calculate work done by gravity. So I'm going to calculate work done by gravity is equals to gravitational force, which is weight, displacement, cos angle between gravity and displacement. So in this case, gravitational force, weight is downwards, displacement is to the right, so the angle between them is 90 degree. So again, if you substitute angle 90 degree, cos 90 degree from the calculator, you will end up with 0. So the answer here would be straight away 0 joule. So what does it mean? It means that work done by weight and work done by normal is 0. No work is done for both of these forces. So the next part is D. So D, what they ask us to calculate work done by frictional force. So I'm going to apply equation work done is equals to force, in this case is frictional force, displacement, cos theta. This one I'm going to expand frictional force, which is mu n as angle between frictional force and displacement. So if you look at the diagram, frictional force is to the left, displacement vector is to the right, so the angle between them is 180, right? Opposite direction, 180. So 180 from the calculator, you will end up with -1, right? Substitute in our coefficients of friction, which is given in the question, 0.4. The normal force we have calculated early on, right, which is 150.79 Newton. 150.79, and then displacement is 0.8, -1. Here I will end up with my work done will be -48.25 joule. Alright, this is the work done by frictional force, which negative represent work done by the system. Okay, now we look at question part E, the net work done. So in this case, if you want to calculate net work done, we can apply work energy theorem, which state that work net will be equals to change of kinetic. So if you look at the question did say is a constant velocity. So if it's a constant velocity, if you want to expand this into half mv squared minus half mu squared, since that your v is equals to u constant velocity, so you will end up with 0 joule. So that means that in this case, since that it's moving with constant velocity, that means no work is done.